Talk about solving systems of linear inequalities. Okay, so inequalities, yep, inequalities means not necessarily equal to, but could be greater than, could be less than, or could be greater than or equal to, or less than or equal to. So what do you need to know after this lesson? Well, you need to be able to graph a system of inequalities. You need to understand where the solution for the systems are located on the graph. And you need to know that a solution to a system will satisfy all the inequalities in that system. Okay? So what we know how to graph linear inequalities. Boom. We know that all shaded points are solutions to an inequality. What's new is when we graph multiple inequalities, the solutions are in the overlapping region. The solution is in the overlapping region. So as we look at example 1, we can see that it has the green inequality has all of these as solutions, and the orange inequality has all of these as solutions. So the only place that the solution to the system is in here. And also be really mindful that this line is solid, which means we include all of those, and this line is dotted, which means we don't include all of those. So if it's on that line and it's dotted, you don't include it. It's not a solution. But if it's on that line and it's solid, you can include it. Okay, let's erase that because I made a mess. Okay, cool. All right, so we're going to see if with these following pairs of solutions are a solution to the system that's graphed. Okay, the first one is 3, -2. So we go to 3, -2, and that is in our area. So the answer is yes, because it's in the overlapping area. The next one we're going to look at is 2, 6, 2, and 6. Now, notice that is on the dotted line. So no, it's not a solution because it's on the dotted line. I maybe should have done that in a different color, but that's okay. The next one is 3, 1, 2, 3, and -2. Oh man, I have the same. So just disregard that one. Let's actually make something different out of that one. Let's make this one a -3, -2. So we'll go -3, 1, 2, 3, -2. Okay, that falls outside the shaded region. So that is also a no. Okay, so change that to a -3, by the way, guys, don't forget. Okay, hopefully I've changed it by now. So now the next one is -6 and 0. So -6, 0 is right here. Now that is on a solid line, but you see how it's not on this part of the solid line, which is included in the orange shaded region. So unfortunately, let me go back because I didn't want to erase that. So unfortunately, that is not going to be in the solution region. So no, not a solution. Okay, now let's make it purple. So 6, -4, 6, 1, 2, 3, 4. Oh, that is on the line. That is solid, and it's part of the overlap. So yes, it is in the solution. So hopefully you guys tried those and you got those right. Okay, so now we're going to graph the solution to this linear inequality. Now, a little reminder, our boundaries, if it was y equals a number, it's going to be a horizontal line. X equals a number is a vertical line, right? So when you don't have an X, it's going to be a horizontal line, and when you don't have a Y, it's going to be a vertical line. So the very first one you see does not have an X. So it's going to be a horizontal line at 4. 1, 2, 3, 4. But you notice how there's no equals. So remember, if we have this, it's going to be a dotted, right? If we had this, it would be a solid, right? But we have dotted, so we're going to make our boundary dotted. And this is talking about all the y's that are less than 4. Well, I think that's kind of obvious. You don't really have to pick a point for that. It would be down here. But if you wanted to pick a point, you could pick 0, 0, and you could see that 0 is lower than 4. Okay, so we shaded towards 0. Okay, cool. Now let's do green. So this is in standard form. So I'm going to go ahead and get the intercepts and see if that helps. So I'm just looking at the boundary So I'm looking at just the line, right? So we're going to do the inequality later. So if I made the x 0, holy schmoly, hold on. So if I made the x 0, you could see that our y would have to be negative 6. So 0, negative 6 is going to be our y-intercept. And if I made the y 0, now x would be 4. So this would be 4, 0. And that's our x-intercept. And so our line also has this symbol. So we're going to make it solid. And I'm going to do my best that I can to draw it. And now I need to decide which half plane I'm going to shade. So what are the half planes? Well, you have a pink half plane on this side, and you have a blue half plane on the other side. You have to decide which one it is. Well, I'm going to look at the pink one, and I'm going to go ahead and plug 0, 0 in. So 3 times 0 minus 2 times 0 is less than 12, or equal to 12. Is 0 less than or equal to 12? Yes. So since that is true, we are going to be shading the pink portion, okay? So I'm going to shade it a little bit nicer than that. Okay, now where's our solution? Well, let's make our solution pretty dark. So our solution is where it's orange and green, right? But we can't lose sight of the fact that we have a dashed line here and a solid line there, right? Solid and then dashed. Okay, awesome. Okay, now we're going to do... Okay, so sorry it cut off before I did the last problem. Let's see. So a purse maker needs to make at least 50 purses a day, okay? And they have to make at least twice as many small purses as large purses. So now we're going to have to get two inequalities out of this and then pick some points that would be in the solution. But here's the deal. What are we talking about? We're talking about small purses and large purses. So first of all, we know that the amount of purses altogether have to be greater than or equal to 50 because I need at least 50, which means like a number that would be at least 50 would be like 53, right? So if I put 53 here, that would be bigger than 50. So that's how you can remember which way it would go. So let's graph that one first. And actually, let's make it green so that I know. I know it's weird. Okay, so if I went to go get the x-intercept and y-intercept, I would have 0 going in and getting a 50 out, and 50 going in, or 0 going into y and getting a 50 out for x. So we would be about here and here, and we're calling it a solid line because it could be 50. Now, let's figure out which side it would be. Would it be on the green side or would it be on the blue side, right? So let's pick a point, 0, 0, and let's put 0, 0 in. Is 0 plus 0 greater than or equal to 50? No. So the green side is definitely not a go. So we're going to have the blue side. So let me actually do this a little bit nicer. Not really great, but nicer. Okay. Now let's talk about the next statement. The next statement says we have to make at least twice as many small purses as large purses. So if we were looking at these are the small purses and these are the large purses, you can visually see that we'd have twice as many, right? So we called the small purses X and we called the large purses Y. So we need to, if I wanted to talk about making things equal, we would have to have 2 of the Y's, right? But we're saying that we could actually have more of the X, so this guy could be bigger. Okay, now don't get tricked as I did. You want to make sure, and I'm going to make this pink, you want to make sure that you get the Y alone because that's how we graph, right? So this is Y is less than or equal to 1/2 X plus 0. Okay, so we start at 0 and we're going to go up 1 and over 2, up 1 and over 2, up 1 and over 2, etc., etc. And we're going to make this solid because it can be twice as many or it can be bigger. right? Okay, well, that's the best I can do. Now we're going to decide which side we would shade on, and let's call it yellow or pink, okay? So we have 0, 0 already there, so we're not going to pick 0, 0. What if we picked 0, 20? What if we picked 0, 20, okay? So if I put 0, 20 in, and let's do it to this one. So we'd have 20 is less than or equal to 0. Is that true that 20 is less than 0? No. So this guy is not a solution, right? So this guy is not a solution, which means we would have the pink zone. The pink zone would be the solution. Okay, so let's talk about this zone too. The pink zone is the solution for this pink one, right? But we also want to remember that if we're going to make a purse, we're not going to have negative purses, right? We're not going to have negative purses. So let's go ahead and look at what our solution would be. It would be in here, right? But it's going to stop where the negative line is. It's actually going to stop right here because we could have 0, but we're not going to have more than that. So this is kind of the way we have to kind of look at what we're talking about and not just our graph. Okay, so let's talk about some numbers, because like if we were to pick a point down here, if we were to pick a point down here, this is 100 and negative 20. That is 100 small purses, and I owe you 20 big purses. Well, you're not going to have I owe you 20 big purses, so that does not make sense. So nothing down there makes sense. So technically, we are only talking about that one dark area right here. Oh, no, I didn't want to erase. So we are only talking about any points that are in here. So like we could do 120. We could do, let's see, what's another easy one? We could do 80 and 20 because it's on the line. And we could also do, let's do one that's in the middle, 140, 140, and 20, right? Because those are at least, right? So these are all possibilities, and they're all in this region right here, right? They're all in this region right here.